In this video, I'm going to be going over the gradients of a linear function. Now, what we know about gradients is that it is the steepness of a slope, or it is just written as the slope. So if we were to consider let's say a random line, and I'm actually going to save on the explanation on the rise and run. So if you are in grade 10, I'm pretty sure you may have heard some teachers would talk about something maybe about the rise and run, right? So we have a line of a gradient, we don't know the gradient, so I'm just gonna write down we're working with a gradient. So let's say they give 2 points, right? Like this, and a point over here. And then we would talk about a run, which is our horizontal line, and then our rise, which is a line that goes all the way from the horizontal line all the way to the next point over there, such that we actually get a right angle triangle. I know it's not the best line, but I don't want to take too much time trying to draw this stuff. I'm not an artist, I'm literally a mathematician here. So they just say that this is represented as your rise, and this is going to be represented as your run. And this is where we actually use our formula. The gradient is going to be equal to your rise over your run. That's just how they explain it generally in the form of trigonometry as well, because trigonometry is included. But right now I'm trying to do it in a way that you can understand that we don't have to use trigonometry. Obviously here, I still have to add the coordinates, obviously. We have these coordinates as, let's say, x2, and this one over here is going to be y2. And then this set of coordinates, we're going to call this x1. And this one over here is just going to be y1. And that is what we are representing on the gradient, on that slope of the linear function. We are going to be talking about how we determine the gradient. But in this case, I have an amazing method that will actually really assist you in answering all these questions with efficiency. So let's move to the examples. Now, with all of that out of the way, let me introduce you to the gradient formula. Now, remember the gradient formula I just gave you? It was the rise over the run. Now, this is our gradient formula in this case. So, the following will happen over here. We have the change, it's going to be the change in y all over the change in x. Now, students wouldn't really like the way it looks, but what this is just talking about, and we are going to break them up so that we actually get the full formula that you are so much used to right now and that you always use in order to answer the questions. We have the following: the y2 minus the y1 is all over the x2 minus the x1. Okay, so right now we can consider these numbers as sets. So set 1 and set 2, right? Because when we want to calculate the gradient using this gradient formula, right now we're not really going to focus on this one, because it's kind of explaining what is this formula about. And they're talking about the change in the y coordinate sets, and also the change all over the change in the x coordinate sets. That is what the delta means. This is capital delta in Greek, in the Greek alphabet. So that's not too important right now. What we're going to be focusing on is how do we actually determine the gradient using the formula. Now, we do the following. Okay, let's consider the following example over here. I wrote down a gradient formula right over here so that we actually see what we're going to be dealing with. Now, let's follow the following steps. We are given a linear function, but we are not given its equation. But the only information that they do give us is two coordinate points. They give us a coordinate point here and a coordinate point over here. So they give us 0 and 2 and 1 and 0. So basically a y-intercept and x-intercept of the function. Now, the only time that you can use the gradient formula is if the 2 points are both on the same function. if it's on a different function, if you get 1 point on one function and the other point on a different function, therefore you can't use the gradient formula, because remember, we're talking about the gradient of that specific slope, basically of that specific linear function. So it can only be 2 points on a specific graph. So how do we actually use this formula over here, this gradient formula? Now what we can see over here is we have y2 minus y1 all over x2 minus x1. Now we are probably wondering, how on earth will we actually determine which one is going to be how do we understand the numbers as the subscript of the variables? Now this is a step that I use. This is a method that I use that actually works all the time. So let's just take those two functions. Okay, this was from the previous video. Okay, so let's do the following. We have the coordinates 1 and 0. So let's just say we have 1 and we have 0. And we also have 0 and 2. Now, what do we do in order to substitute this or plot those values into the coordinate, into the formula that we have, which is the gradient formula? Now, what we can do, right, is let us consider, remember what I said in the beginning, these numbers over here, which is the 2 and the 1, for both of the numerator and denominator, these are considered as sets. So what I would normally say is that we can call these different coordinates a different set. So let's say that this coordinate is going to be set 1. And then this coordinate over here is just going to be set 2. It doesn't matter which one you call set 1 or set 2. It doesn't matter the order, just as long as you have a set 1 and a set 2. You can't call both of them set 1 and you can't call both of them set 2. And this is why we call them set 1 and set 2. Because this is set 1, remember we have x and y coordinates, right? We have this 1 is the x coordinate and this y is the x coordinate. But because it falls under set number 1, we can call this x1 and we can also call this y1. And then if we look at the second set, in this case over here, we can see, remember once again, we have an x and a y coordinate, but then we can consider this x coordinate as x2 and this y coordinate as y2, because that is within the second set. Now, what can we see over here? We have x1 and we have y1, we also have x2 and we also have y2, which is basically all in our gradient formula. So that's what we do. We use the gradient formula and we just plot in the values. So if I were to just take this gradient formula over here and just copy and paste it, because let me just get this thing sorted over here. Okay, so here's our gradient formula, right? So we're just going to plot in the values right now. So m is just going to be equal to, let me get the coordinates here. So set 1, what do we know? Okay, so we first want to look at y2. What is y2? We can see that y2 is right over here, which is just equal to 2. So we can just plug in 2. Minus, and then what we're going to do over here, where is y1? y1 is right over here, which is equal to 0. So we can just plot in 0. All over, and then we have x2 minus x1, so we see x2 is just equal to 0, and x1 is just equal to 1. So it's 0 minus 1 in that case. So it's 0 minus 1, which is just going to be equal to 2. 2 minus 0 is just equal to 2, and 0 minus 1 is just equal to negative 1. So therefore, this gradient will just be equal to negative 2 in this case. And that is how we determine the gradient with the gradient formula. Let's do one more example to actually understand what we have to do again, because I feel like this was very abrupt and start, and this is my own method that I use. And if you use this, then it's gonna really benefit you. So let's do the last example of this video. So for this one, I thought the best way to do this is actually to do the weirdest one possible. Now, I gave you two coordinate sets. Now, the last one, we actually dealt with the coordinate points where it was on the x-axis and the y-axis. So basically the x-intercept and the y-intercept. But this time, I just gave you two random points but remember, they both lie on the same function. So therefore, we can actually find the gradient of this one. So the one point that we have over here is going to be -2 and -1/2. Then the other coordinate is +3 and -4. So that is what we have at the moment. So let's determine the gradient. It's actually really, really simple. So let's do the following. Okay, so I wrote it down over here, right? We have -2 and -1/2, and we also have the coordinate set 3 and -4. So in the last example, we actually named our sets. So let's do the following, right? Let's call this set 1, this coordinate set over here. So we're going to call this set 1. And then we're going to call this coordinate set 2. I recommend doing this in pencil and then erasing it afterwards in your question paper or your solution paper. Or if you want to do it on the question paper, then go for it as well. But right now I'm just doing this so I can show you how we can go about solving this. So in set 1 we have x1 and we have y1, because remember that's our x and y coordinates within set 1. And then within set 2 we have x2 and we have y2. And those are our values that we can plug into the gradient formula. So that we can do that. Okay, so therefore we're going to have m, the gradient or the slope, which is equal to y2. y2 is equal to -4. And this is where it gets a little bit tricky, and I'm going to show you what you need to consider. Minus y1. y1 is just equal to -1/2. Now, remember the gradient formula is when you have y2 minus y1. But when we are minusing by a negative number, or whenever we are plotting a negative number into the gradient, please always remember to put a bracket here. So we're going to say this is -1/2 within the bracket, because I'm going to show you exactly why we do that in this case, because it's important to put that bracket there. I'm going to tell you why. And then we have x2, which is equal to 3, and then minus x1, which is just equal to -2, which we put in a bracket because it's a negative number. And therefore, we can simplify it further. Let me just do it here. We can simplify it further, where m is just going to be equal to -4 minus -1/2. So therefore, for this one, we can say that this negative multiplies into this bracket such that we get a positive value in that case. So we're going to say that this is going to be, I'm going to do it step by step, -4 plus 1/2. Because the negatives multiplied by each other and to give us 1/2. Negative and a negative gives you a positive. Now, for this one over here, for the denominator, we have 3 minus -2. And 3 minus -2, where we have this negative over here, which is going to multiply into this bracket so that we can get a positive. So therefore, the answer, or it will look like 3 plus 2 in this case. Now, we simplify now further. -4 plus 1/2 is just going to be equal to -3,5. But what I want to do is I want to write this as a fraction in this case. And I'll show you why we want to write it as a fraction. So this is actually just going to be -7/2. So we're going to have -7/2. All over 3 plus 2, which is just equal to 5. And then right over here, we can just tip in times, which you should know by now. It's going to be -7/2 multiplied by the reciprocal of the denominator, which remember the denominator is dividing by 1 initially. So we're just going to flip them around in this case. Because remember it was initially dividing, so now we're going to multiply it this time, and we're going to multiply by the reciprocal, which is 1/5. And therefore we're going to get an answer over here of -7/10. And that is going to be our gradient in this case. That is going to be our gradient value. The gradient is equal to -7/10. And we can clearly see the gradient is also negative over here. And it is a very, yes, it's just in that direction. So that is what we have to do when we have negative numbers in our coordinates. What we have to do is, first of all, remember the steps. Set 1, okay, we have to create our sets, right? Set 1 and set 2. Then we need to plug into the equation with our set of coordinates. And whenever we have negative coordinates, we have to plot, whenever we're plotting negative coordinates, we are always going to plot it in with brackets around it, so we can multiply the negative with the negative to give us a positive. And then we just simplify further to actually give us the final answer of m is equal to negative 7 over 2. And that gives us our gradient. In the next video, I don't have to explain the c. Remember, the c was actually just going to be equal to your y-intercept, right? So your y-intercept. So I don't really need to explain that. Whenever you see like your c value is equal to, like, let's say negative 5, then you know that the y values that the function intercepts is just going to be negative 5. So there's nothing too hectic to go about that for. So this video is purely based on gradient, and then the next video we will be determining the equation of the function.